Welcome to geometry. Geometry for most of you is going to be your first taste of rigorous mathematical proofs. But if you study advanced math, it won't be your last taste. In fact, advanced math is all proofs. That's all you do in advanced upper level math. Whether you're studying something like abstract algebra, number theory, topology, calculus of manifolds, you name it, all you do in advanced math is proof. And this is going to be your first experience of it. I've drawn a picture, I've taken this picture here of a maze to illustrate what a proof is. We'll call this the starting point and this the ending point. If somebody asked you to solve the maze, you wouldn't just say, well, here's the end, here's the solution. You don't just point to the end. Solving a maze means creating a path, drawing a path from the beginning to the end. And until you've made that complete path that gets you all the way there, not just close, not just halfway, but all the way from the beginning to the end, you haven't solved the maze. Similarly, in a mathematical proof, you need to show every single step, bit by bit, from the beginning to the end, that connects you from the question to the solution. Now here's something interesting. For most mathematical proofs, the answer is given. You already know the answer. You know the question, you know the answer. All you need to do is find the sequence of steps that can get you from the question to the answer. Let's go ahead and look at a famous proof. I've written over here the Pythagorean theorem. A squared plus b squared equals c squared. You're probably familiar with it. And you know that there you can get whole number solutions to this. For example, a could be 3, b could be 4, and c could be 5. Note that they're all whole numbers and it works over here. Or you could have 5, 12, and 13. Again, whole numbers work. However, if you have a to the n plus b to the n equals c to the n, and n is a number bigger than 2, so if it's 3, 4, 5, 6, 7, whatever, then there are no whole number solutions that will work. That if this is a cubed plus b cubed equals c cubed, there are no whole number solutions where a, b, and c are all whole numbers. That theorem is called Fermat's last theorem. It took the human race a few hundred years to figure it out. The person who actually figured it out was relatively recently. It took him 35 years to figure out this proof. Proofs are difficult, but notice this. Everyone knew the answer. The answer is that it can't be done. So everyone knew the answer before he began the proof. This wasn't about finding the answer. It was only about finding the steps that connect the original step to the final step, that connect the question to the final part of the solution. Let's take a look over here. I'm going to show you what a proof looks like using a simple algebraic equation. Given that 2m plus 6 equals 10, prove m equals 2. I'm going to show you what a solution to that would look like. The first thing that you're going to do in every proof, every single proof you do will start in the same way, where you're going to rewrite the information that's given, and your reason is always going to be the same thing. Given. Notice I have two columns here. I have a statement column here and a reason column here. I write the statements one at a time until the last statement, and the last statement needs to be what you're trying to prove. So the first thing is given. Now I get 2m equals 4. How did I get that? I subtracted 6 from both sides, and so the reason is the subtraction property of equality. Finally, I divided both sides by 2, and then I get m equals 2, and the reason is the division property of equality. Now, some of you who want to be fancy, might add an extra step at the end where you basically say that again and write QED. QED means quod erat demonstrandum, which means which was to be proved. It just lets you know that you did the final step. You proved what you were supposed to prove. Whether you include that step or not is up to you. As somebody that likes Latin quite a bit, usually do include that in my proofs, but that's to a certain extent a stylistic thing. Some people who are very formal about proofs say you absolutely have to write that. Other people say it's kind of optional. Whatever you want to do, go ahead and do. Now that you know what a proof is, in later videos we're going to talk about how that's influenced geometry and why are proofs good in the first place.